might have S, I, and R be associated with person as a unit. Beta is a likelihood, so it's of dimension 1. C, the contact rate, person per time that a given person sees. So person per time per person. So it's dimension 1 over time. And this could be calculated from data on contacts of n people over some time interval, for example. And mu here will be time, the time to recover. And that's a consistent labeling of the different dimensions associated with this. Now, if we have a force of infection, you'll notice that this all makes sense. The force of infection, the dimension associated with the force of infection, this says units, but it should say dimension. The dimension associated with the force of infection is just the dimension of C, 1 over time, times the dimension of I over S plus I plus R. What's the dimension of I over S plus I plus R? Who could tell me what the dimension of this is? Of this quotient here? What's the dimension of I? Speak. Person. What's the dimension of the denominator? Person. So what's the dimension of I divided by S plus I plus R? Dimensionless. Exactly. It's a fraction, right? Dimensionless. Does it depend on whether you count people in thousands or in individual people? No. Because if you're counting people in thousands, then that would affect both the numerator and denominator, so you still get a fraction. If you're counting them on 1 by 1 by 1, then you also get a fraction out. So that's dimensionless. And the dimension associated with beta, which is kind of hidden behind there, is dimensionless also. So the dimension associated with the force of infection is just dimension of C times dimensionless times dimensionless. In other words, it's dimension of C, which is 1 over time. And that makes sense. You have a certain chance per unit time of being affected, a certain fraction of the time. In other words, per unit time, you're going to be infected, a certain fraction, okay? And this makes a lot of sense. You multiply the force of infection times S. Force of infection is just this chance per unit time you get infected. You multiply it times S, and it gives person per time who are getting infected. That's the rate of flow, number of infectives per unit time. Alternatively, you could just consider the reciprocal at that time. If we have a chance per unit time being infected, the reciprocal is just how long on average it takes us to get infected. So it's going to be a time. So its reciprocal has to be a time. So its dimension is 1 over time. Okay, let's talk about how you do this in VenSim.